Okay, good evening, you guys. Today we're going to be going over and reading our electricity book to help us learn more about electricity. Okay, first thing we're going to do is we're going to go over our lesson plan to help us better understand what exactly it is that we're going to be learning about today. Okay, so for our learning objective for this lesson, given a list of tools, students will be able to properly create a functioning circuit. What's a circuit, you ask? We'll find out here in a bit. The students will be able to demonstrate how to combine a series and a parallel circuit. Students will be able to properly identify the insulators and conductors. Students will also be able to evaluate different power sources and their effects on what it is they're going to be using. Students will create a functioning parallel circuit with renewable energy. That's going to be a lot of fun. Okay, so 3 essential questions that we're going to be learning about today. Okay, I want you guys to be thinking about this during our reading. All right, what is a circuit referred to as? All right, what is an everyday renewable and natural resource that we can use to produce electricity? How much? How can you make? Excuse me. How can you make a static charge last longer and be more powerful? This is going to be pretty fun. All right, some materials that we're going to need. We're going to need our student laptops, our books app from once we get them downloaded, and student participation. Okay. The learning objectives for this is how we're going to do it. Basically, we need to make sure that our laptops are charged and that they're ready to go. And if they're not, go ahead and plug them in at the beginning of class here once the bell rings. All right. We'll read the book out loud and then make sure everyone's following along. We're going to take a little book quiz that is inside the book. We're going to partner up afterwards to conduct or to make one of the circuits of your choosing, either parallel or series circuit. Okay. Afterwards, we're going to assign our homework to find out 3 more natural resources that can be used and harnessed as renewable resources. Okay. In class, we're going to talk about some of the stuff during the we're going to talk about how to make a series circuit or a parallel circuit. But in class, we're going to be a little bit safe about it. So we're going to conduct, a series circuit with 4 copper wires, 2 light bulbs, and a battery. Okay. Afterwards, we're going to pass out the homework, like I said, and then that way you guys can have an idea of what a renewable resource is. Okay. For your guys' assessment or your test, if you will, we're going to see if whether or not you can make a series circuit that can produce results with a power source. All right. And then another way we're going to assess you guys is we're going to develop a parallel circuit that produces results with a power source even after part of it has been interrupted. So those might be handy to pay attention to. Okay. All right, let's go ahead and open up our laptops and open up the app Books. That way we can start our electricity learning. Here we go. Electricity, static electricity, if in that manner. Okay. Static electricity is a blast or a zap that happens all at once. An example of static electricity in nature is lightning, because a positive cloud and a negative cloud bump into each other, creating a burst. All right. How you know static electricity is discharged, you can see, hear, or feel the zap. Okay. So an example of it, as you guys can read on the example 1, static electricity moves from you to metal after jumping on a trampoline because you both have different types of charges. Example 2, if 2 balloons were hanging from a point and repelling from each other, it's because they have the same charge. But if water and balloon were attracting, it's because they have different charges. All right. Example 3, and this is my favorite because it happens to everyone. Okay. If you rub your feet on a carpet, then touch someone, you'll shock them. How many of you guys have done that? I know I've done it a lot of times to my brothers and sisters. Okay. Here's a little helpful hint. In order to make static electricity stronger and last longer, you would have to rub your feet on carpet longer. All right, this would make the shock hurt more. So if you ever want to try it right now, oh well, carpet, keep rubbing your feet super fast, super fast, super fast, and then stop, and then touch your partner. But don't do it right now because you might hurt them, okay? All right, go on to the next page. If my book will let me. All right then. Number 2, current electricity. We're going to talk about current electricity. Current electricity is a steady flow of electricity. There are 2 types of circuits: series and parallel. The series circuit is, picture this, okay? The series circuit is just a big pathway. If you break one pathway in it, then the whole thing will not work. All right? A parallel circuit is a pathway where electrons go through many different ways. If one light bulb goes out of the rest of them, if one light bulb goes out, the rest of them stay bright. The more batteries you have in the circuit, the brighter the light bulbs get. Some examples of current electricity are a computer, televisions, refrigerators, and a cell phone charger. Okay? Here's that little quiz that I was telling you about. Question number 1. Are you guys ready? Okay. What is the definition of current electricity? Choice A, a steady flow of electricity. Choice B, it happens all at once. C, an offspring, or D, all of the above. Moving on to question 2, you guys. Give an example of current electricity. All right. Is it A, computer, B, an oven, C, a microwave, or D, all of the above? And lastly, what is not a difference between static and current electricity? Metal, battery, switch. Static is a steady flow. Remember, all right? Okay, let's go ahead and move on. Insulators and conductors. This is one of my favorite parts right here, okay? An insulator is something that does not let electricity go through it. Remember, an insulator does not. All right? A conductor is something that lets electricity go through it. All right? Some examples of insulators are glass, wool, paper, plastic, and fabric. Okay? Some examples of conductors are water, people, because we produce electricity too. Remember how I said if you rub your feet, you shock someone? Paper clips, and metal, iron, nickel, etc. Any type of metal that you can. All right. If you look at your books, it gives you actual pictures. That way you guys can put pictures and words and think about them maybe for later on to make a circuit. Okay. Paper clips, what are they? A conductor and insulator? Good answer. It's a conductor. All right. Plastic, is that an insulator or a conductor? It's an insulator. So, funny thing about plastic, remember, insulators don't allow electricity to go through it. So if you try to protect yourself with plastic, you're going to have to make sure you have a lot of it. So however powerful that electricity that's coming through to you, the plastic can stop it. But plastic, once it gets super hot, it melts. So be careful. All right. A book is another insulator, right? Because remember, paper. And lastly, and the most obvious of that everyone should know, water is a serious conductor, for real. Okay. All right. Next page. Series circuit. This is the one we're going to do in class, but I have a more better depiction for you guys. Okay. The book reading, it says a series circuit is a type of current electricity. Okay, so picture this. All right, you're standing in the middle of nowhere, and you have 3 items with you. Okay, you have a bucket of water. Now, this bucket of water could be a small little cup, a huge bucket, or a tub full of water. This is going to come handy later. All right. Now, that water that's in the bucket is going to create a stream. That'll be your current. All right. The bucket of water is the battery source. Okay. And now Picture a river wheel. Okay, you can depend. It can depend on being small, medium, or very large. Excuse me. All right. So let's talk about the flow of that circuit itself. Okay, the bucket of water. You're going to dump it into a tub where it's going to produce that stream, that current flow, right? And however fast or the amount of water that's going to produce to cause the river wheel to spin is going to be on how fast again or how much that the amount of water is in that bucket. So if the river wheel starts spinning super fast, that's because there's a high current, so a lot of energy going through this. And then that bucket, not that bucket, but the river wheel can be attached to, say, light switches, a fan, anything that you want it to produce something, you know. And that's basically your circuit. Now, where this can be combined with a parallel circuit, we'll learn about that here in a bit. Next page. So a parallel circuit, okay, is a parallel circuit is a type of current electricity. All right. So for this one, think now you have two of the same exact items that we just had, like your depiction says on the book and the examples. We'll do that later for the in-class assignment. All right. But if you have two buckets of water on two different sides, right, and then you're creating that stream with the amount of water, and then you have two river wheels. Now they're both spinning. So when they're combined, if you put those two streams, if you make some type of connection to them, now you're going to have water flowing through it. That can either slow down or speed up that process of the river wheel and how fast it spins. Okay, so if you stop one of those buckets of water from flowing, you still have that other one continuously feeding both of them. So less water, less amount of current or speed that river wheel is going to spin at. All right. So if you stop one, you still have one connecting it and giving it energy. Of course, you're going to have a constant supply of water. All right. Next page. And that is it. Well, you guys, hope you guys had fun. I did. You guys have a good one, okay? We'll go now into our assessment to create an in-class parallel circuit or a series circuit.